Good day to all. Today we are going to present a subject on vapor absorption machine. Thanks to ISHRAE for organizing this topic wherein me, Srikanth from Rithvik Consultants is going to get into them. And I'm here, it's a privileged opportunity for me to talk about vapor absorption machine on behalf of ISHRAE Chennai chapter. Before getting into the details of vapor absorption machine, I would like to touch base some basics about VAM. Not only VAM, it's a basics basically. On the basics, what we are going to do is, what is refrigeration? A refrigeration is defined as a process of extracting heat from a low temperature, medium, and transferring it to a high temperature sink. Let's say in an AC term, in an air conditioned space, I am removing the heat from a cold room and distracting or rejecting it to the atmosphere where it is already hot. Further, I would like to touch upon pressure-temperature relationship. Pressure temperature, we all know, for an easy example, we know that water boils at 100 degrees centigrade at 1 atmospheric pressure, which is nothing but 760 mm of Hg. Now, surprisingly, when I reduce the pressure from 760 mm to 6 mm, it will be astonishing to note that water boils at 3.5 to 4 degrees centigrade. This technique is what is majorly adopted in vapor absorption machine. Further, let's touch base some more basics of latent heat. What is latent heat? It's the heat required for changing a substance from one form to another. To elaborate, let's say water, when it boils at 100 degrees centigrade, it slowly converts into vapor at same 100 degrees centigrade. That means there's a change of phase happening in the water, wherein the water becomes vapor at 100 degrees. This is called latent heat of vaporization. Likewise, the 100 degree water vapor, when I remove the heat from the vapor, it gets cooled and it forms as water vapor. It forms as water. That's nothing but latent heat of condensation. So the difference between vaporization and condensation is nothing but change of state of phase of a liquid. Now what is sensible heat? Sensible heat is nothing but a temperature. By supplying heat, I'm just increasing the temperature, but there is no change of phase. For example, the water can be heated from 30 degree to 40 degree, 40 degree to 60 degree. Still, water is a water. There is no change of phase. That's called sensible heat. To elaborate further, let's get into the core of the system. Cooling. How do we meet a demand of cooling? Cooling can be met in two ways. One is vapor compression system, one is vapor absorption system. Now, let's talk about the difference between the compression system and the absorption system. Now, what is compression system? A compression system has a chemical energy, heat energy, mechanical energy, electrical energy, heating and cooling. Likewise, an absorption system has a chemical energy, heat energy, and then cooling and heating. The major difference between an absorption and a compression system is, in vapor compression system, the major component is compressor. If the compressor is replaced by an absorber and generator, then it becomes an absorption system. As said, absorption system works on a primary heat energy. How does the absorption machine work? Now let's get into the real chapter. Absorption system works with two basic chemicals. We call it as chemical, but it's basically a salt. And the salt is nothing other than lithium bromide solution. Lithium bromide is similar to sodium chloride salt, but only difference is lithium bromide is highly hygroscopic in nature. The meaning of hygroscopic is nothing but it can absorb moisture very easily. Let's say, for example, a drop of lithium bromide drops in my skin. I can see the place dehydrated so fast because it absorbs the moisture from the skin instantaneously. So lithium bromide having a property of highly hygroscopic in nature. And refrigerant, to a greater extent, we will be shocked. In vapor absorption machine, the refrigerant is nothing other than DM water. As said earlier, is used as a refrigerant in vapor absorption machine. That's the purest form of green available with us, which is used in an absorption chiller as a refrigerant. Now, we talk about the pressure-temperature relationship. Water boils at 100 degrees centigrade at 760 mm of Hg, which is nothing but 1 atmospheric pressure. Surprisingly, the same water will boil at 175 degree approximately when the pressure reaches 10 kg per centimeter square. Now, let's see how this difference in pressure temperature gets into the absorption system, the working of absorption system. Now, basically, an absorption system works with a vacuum. For example, let's take a cylindrical shell, wherein its vacuumization is happening and the vacuum of a cylinder is maintained at 6 mm. And I have water inside it. As said earlier, this water will boil at 3.7 or 4 degrees centigrade. When I circulate the chilled water at 12 degrees centigrade, I have a difference between 12 and 4, which is around 8 degrees centigrade. And this 8 degrees centigrade is used to cool the water. Now what happens? When this 12 degree chilled water enters into the machine, the water inside the cylinder sprays over the tubes of the chilled water. So it picks up the heat of 12 degree and cools it up to 7 degree by latent heat of vaporization. That means the water picks up the heat and it becomes vapor. So one side, when I spray the water, it picks up the heat and it becomes vapor. Now assume on the other side, as said earlier, when I spray lithium bromide solution on that to a concentrated lithium bromide, already lithium bromide is having a higher affinity towards water. So when I spray lithium bromide, the water vapor gets attracted towards the lithium bromide due to its affinity of property, and the lithium bromide becomes dilute solution, because concentrated after absorbing the water quite naturally becomes dilute. This dilute lithium bromide is taken further one more cylinder, which is called a generator. Now what happens in the generator? I supply heat energy. This heat can be in the form of hot water, steam, or it can be even an exhaust gas from an engine, which is used to generate power. When this generator is exposed to a heat energy, the lithium bromide solution boils. As said, lithium bromide has a boiling point of 1200 degrees centigrade at 1 atmospheric pressure compared to water, which is at 100 degree at 1 atmospheric pressure. So when I expose the solution to heat, the first thing which gets evaporated will be water. So water gets vaporized, leaving the lithium bromide solution to further concentrate. So this water vapor is taken away to the condenser, where I circulate the cooling water. When the cooling water enters into the condenser, latent heat of condensation happens. So the vapor immediately gets cooled by the cooling water and it becomes condensed liquid. This condensed liquid is brought back again to the evaporator, wherein the water boils at 3.7 and the cycle is repeated. Now to repeat the cycle, I need to bring the lithium bromide, concentrated lithium bromide, back to the absorber. So this is again done with a pressure difference. The generator is exposed to high temperature, wherein there is a high pressure. Your absorber is exposed to a low pressure. So there is a difference in pressure. Quite naturally, the solution from the generator comes back to the absorber. There is a free flow of solution happening. Likewise, as I said earlier, an example of when you have a salt, just add 2 drops of water, you can see there is a heat dissipation. So the concentrated lithium bromide sprays in the absorber, and this concentrated lithium bromide again picks up the water vapor, and just the cycle is repeated. So in a vapor absorption machine, one time if you charge lithium bromide and water, it's more than enough, wherein there is no need to add on frequently of lithium bromide because it's a closed cycle. Now having looked upon the working of lithium bromide absorption system, let's talk about the VAM products, availability of VAM products. VAM is available in 3 types: single effect, double effect, triple effect. In single effect, it's again further classified as it can work as a hot water single effect machine, steam fired single effect machine, and in a double effect machine, it can be again a hot water, because as you recollect, I said 10 kg pressure, water boils at 175. So if I maintain a pressure of 20 kg, the water can be in water at 175, 180. So that can be used as a double effect hot water VAM. Likewise, steam at higher pressure can be used for double effect, and little more higher pressure, it can be further used as a triple effect machine. Then comes the exhaust machine. The exhaust fire machine works on the exhaust gas from the generator, which we normally leave it to the atmosphere at a high temperature, whereas in VAM, we recover the heat from 450 degree to 180 degree centigrade, and we are saving the glue by recovering the heat and converting it to as a useful heat energy. So exhaust fired VAM machines are becoming popular. With exhaust fired machine, a jacket water, which is again used in the radiator of the engines, can also be used as a single double effect machine, wherein the hot water will be used as a single effect machine. The exhaust gas can be used as a double effect machine. Combinedly, the machine can be called as a single double effect machine. Now, when we talk about vapor absorption machine, it also has an advantage. The advantage of the vapor absorption machine is it's a huge power saving machine because it has only heat energy requirement. Let's say, for example, a 1000 TI machine requires only 15 to 20 kilowatt of power consumption as against a conventional compression system of 800 or 1200 kilowatt of power. So VAM, when the heat energy is abruptly available, it's one of the best product which can run. And since we use water as a refrigerant, it's one of the green product available in the market, and in India, surprisingly, we get almost 80% depreciation for the first year. The government is helping us in such a way that VAM can be utilized as a green product, wherein you get 80% depreciation in the first initial investment. When I talk about the advantages of VAM, quite naturally there is a limitation or disadvantage. The VAM is very costly compared to your compression system. It's almost 30 to 40% costlier than a compression system. Likewise, it needs cooling water. There is no air-cooled vapor absorption machine available in the market. Cooling water consumption is much more higher compared to a compression system because the heat which is extracted also need to be rejected to the atmosphere. So the cooling water requirement of VAM becomes much more higher. VAM can also be used only up to 5 degrees centigrade or minus 5 degrees centigrade because we use water as a refrigerant. That's again a limitation. In compression system, we can go even up to minus 20 or minus 40. Whereas in lithium bromide absorption system, the limitation is only up to minus 5. So, we all talked about VAM. We know about VAM now on the basics, advantage and disadvantages. Having said about the vapor absorption machine, I also thanks ISHRAE for giving me an opportunity. And this video is going to be lively available for the viewers so that it can be utilized across the country. However, as you likely know, these videos keep on get updated, and so this video is available only for a very limited period, let's say 15 days. So I request all the members to utilize this video and study on VAM and have a look on VAM, how it works and how you get into the details and all. And in case if you have any clarification, you can always contact me at R.Srikanth with the mobile number given below on the slide, and you can always mail me whatever clarifications or doubts, and I'll be very happy to assist you or to render you the reply. Thanks for the time, and thanks to ISHRAE Chennai chapter for giving me this wonderful opportunity.